So in a previous video, we talked about using theta, a Greek letter for an unknown angle measure. In this video, we want to talk about some of the other common Greek letters that you're going to see, and these are all typically lowercase. So we have this guy right here, which is alpha. Whoops. We have this guy, which is beta. Then we have this one, gamma. Some other ones that we use that are maybe not as common. We definitely use alpha and beta a lot. Sometimes you'll see this guy right here, which is mu. And then we have phi. Whoops. More vertical like that. So this is phi. And then, of course, there's our classic theta. We use that guy a lot. The one thing to make sure you watch out for is this guy right here, pi. Don't ever use that as a variable. Pi, you remember, it's an irrational number. It's about 3.14. Yeah, that pi. Don't ever use that as a variable. Even though it is a Greek letter, he's not used as a variable. It's weird and wonky. We don't do that. So we're talking about angles that are in standard position. If an angle is in standard position and the terminal side lies on an axis, then that's called here's a big fancy word for you, a quadrantal angle. So when you think about that on the XY plane like this, that's going to be where your initial side is, I don't want that. Your initial side is going to be along the x-axis, of course. But your terminal side is going to be on one of these other axes. So this would be a quadrantal angle like that, so 90 degrees. Or it could be that it is out here like that, so 180 degrees. Or it might be going on the y-axis below like that, so you would have the angle measure all the way around here, which would be 270 degrees. So these are some common angle measures that you need to know because they just show up all the time. Right? So quadrantal angles, angles whose terminal side lies on an axis. And then we have angles that we call coterminal. And the name pretty much tells you what it is. Co-terminal. Co meaning the same, terminal meaning where you terminate, where you end. So if we were to take, let's draw this angle in standard position. So there's the initial side, and let's suppose that this is the terminal side, like that. Okay, so that this is your angle. For an angle that's going to be coterminal, that means that when it ends, so it's in standard form, and where the terminal side is, it happens to line up at the exact same terminal side of another angle. So that means if I were to take this, if I were to go around more than once, then the angle that's going to be formed here is going to be coterminal to that one. It has the same ending, has the same initial side right here, and it has the same ending side. Now we could go backwards if we wanted to, and we could say, you know what, if I go from here and I go backwards this way, so you would have the same initial side, and the terminal side ends up being where the other guys were. All of these guys are coterminal. They end pointing in the same direction. So even though they might have different angle measures, they all would end up being evaluated the same. So for example, for the first guy that we did, suppose this is 130 degrees. For this bluish one that went around one whole time and then it went around, that would be basically you had a 360, right? You were pointing in this direction. You went around another 360 degrees. So that means 490 degrees ends up taking you to the exact same spot. Or this green one that goes backwards. So since it's going backwards, it's going clockwise. That would have a negative angle measure. So it's 130 going counterclockwise. then the difference between that and 360 is the amount that we have over here, which would be negative 230 degrees. So all these guys are going to be coterminal. And you can see that if you were to take negative 230 plus 360 degrees, you get 130 degrees. And then if you take 130 degrees and you add another 360, you get the 490 degrees that we have. So anytime you add or subtract 360 degrees or a multiple of 360 degrees, you get an angle measure that is coterminal. So now that we've talked about what coterminal angles are, let's do some examples where we need to find angles that are coterminal to another angle. So this example that we have has an angle whose measure is 653 degrees. And what I want to do is we want to find the coterminal angle of least positive degree that is coterminal to 653 degrees. So basically what we need to do is that we need to add or subtract 360 degrees until we get to an angle measure, or theta, that is less than 360, but greater than or equal to 0 degrees. So right now 653 is too big, right? What if I subtract 360, right? If I subtract 360, we get, let's see, that's 3 and 29. Okay, so 293 degrees. Well, that's in between that. So yeah, 293 degrees is coterminal to 653 degrees. So this is the answer we were looking for. The next example has negative 290 degrees. So just kind of picture in your mind what that looks like in terms of the graph. You have your initial side over here, negative 290 degrees. So this is negative 90, negative 180, negative 270, and this is negative 290 degrees. So we can see that if we're going to be coterminal to this, it's got to be in quadrant 1. All right, so if I subtract 360, I'm going to be going in the wrong direction. It's going to make it a larger negative number. But what if I take negative 290 degrees and I add 360 degrees? When I do that, I end up at 70 degrees, which makes sense with my picture. So 70 degrees is the angle of least positive measure that's going to be coterminal to negative 290 degrees. And it's this next one that's going to be kind of messy. Okay, 1,831 degrees. Okay, that's just kind of gross. It's kind of big. And I don't want to have to keep subtracting 360, minus 360, minus 360. Now we can do that. But there are some things to keep in mind, right? So you have 360 degrees is 1 rotation. 720 degrees is 2. 1080 is 3 rotations. 1440 is going to be 4 rotations. How did I get that? Well, this is 360 times 1. This is 360 times 2 times 3 times 4. So let's look at that 1440. I'm just going to grab the calculator real quick just so that we can power through this. So 1831 minus 1440. So that's the thing, we were close. So minus 1440 gives me 391 degrees. That's still too big, right? But it is coterminal. That's what what we need to understand. If an angle measures 391 degrees, it's coterminal with one that measures 1,831 degrees. So if I take 391 degrees minus 360 degrees, we end up at 31 degrees, which is going to be where we want to be. It's in between 0 and 360. It is the angle measure of least positive measure that will be coterminal with 1,831 degrees. Now, the next few examples is tasking us to find 2 angles that are coterminal, one positive and one negative. So if we look at 41 degrees, an easy way to get something that is coterminal and positive to this guy is to add 360 degrees. And so that means that 401 degrees is going to be coterminal. We could also look at this as doing subtraction, right? If I subtract 360 degrees, then I'm going to land at negative 319 degrees. So plus 360, I'm going to be positive. Minus 360 from this guy, I'm going to be negative. And interestingly enough, this angle and this one will be coterminal to each other. Because again, we were at 41 degrees. We went around 360, went backwards 360 from that. So they both end up pointing in the same direction. Coterminal. So let's do it with the other two examples that we have right here. We have 225 degrees. If I add 360, that's going to be another positive one. So that's going to give me 585 degrees. Or if I subtract 360 degrees, that's going to give me 135 degrees, but it's going to be negative. So again, here are the two answers that it's looking for. And same thing for this last problem, 333 degrees. Now this one is between 0 and 360 to begin with. So because of that, if I add 360, that's going to be my first positive one. So 693 degrees. Or if I subtract 360 degrees. So negative 27 degrees. These guys are going to be coterminal. If you think about the graph for this, so know the key measures. So that's 90, 180, 270, 270, and 360. So 333 degrees is going to be somewhere right here where you've gone all the way around like this. So 333 degrees. Well, if you go backwards, so clockwise, negative 27 degrees, you're going to be right there. If you go around the 333 degrees plus another rotation, you have gone 693 degrees. So you've got the one rotation to here, plus the other 333 degrees. So all these guys are going to be coterminal. They all end up facing in the same direction.